In this video, we are going to be graphing hyperbolic functions. This is part 2 of my hyperbolic function graphing series. As of recording this right now, it is July 16th, so it's my birthday. So this year I'll turn 14, and I'm going to 9th grade next year, in the 2025 to 2026, 2026 to 2027 school year. Next year I'm taking trigonometry and AP Calculus A and B. Yeah, and this is the Algebra 2/Pre-Calc curriculum for my school, and these are the worksheets they provide. Okay, so first of all, let's delete all this. Okay, so question 3. So first, let's identify whether this hyperbola is a horizontal hyperbola or a vertical hyperbola. Since the positive term starts with an x, meaning in standard form, this is a horizontal hyperbola. Since in standard form, it begins with an x value. Okay, so then that would mean that our point of center is at 2, 3. Okay, now we do the square root of 12, which is 2 root 3. And which is the square, which is equal to 2 root 3. And 2 root 3 in decimal form is 3.46. And then the root 20 equals 2 root 5. And 2 root 5 in decimal form equals 4.47. And then for C, so that is C squared equals A squared plus B squared. So 12 plus 20 equals root 32. So that equals 5.65. And this does simplify. Yeah, so this simplifies to 4 root 2. Okay, now we have enough to graph, so it's time to graph. So this point is at 2, 3. And now for the vertices. So 2 root 3 equals 3.46. time for the use of the value of b. So 2 root 5 in decimal form. From before, it was 4.47. So that's right around here. And here, 4.47. That's right around there. And now we draw the lines. And then one line down from here. And this, since it's asymptotes, it is going to be dotted. Time to draw the lines. Now I'm trying to select the line. Oh my god. Hang on, let me make the asymptote a bit better. Okay, that's one asymptote. Time for the other. Okay, time for the not the asymptote, the actual hyperbola. Time for the other side. And that is our hyperbola. So now we have to graph the foci. So for the coordinates, this is just based off of the coordinates. This is just based off of the point. So 2 plus or minus 4 root 2 comma 3 so 3 units. So what's 4 root 2? 4 root 2 in decimal form is 5.65. So 2, 4, 5's are right around here. So that's the foci. And that's the foci. In time for the lengths of the transverse and conjugate axis, this is just A and B getting doubled respectively to the transverse axis and conjugate axis. So this would be 4 root 3, 4 root 5. And the domain is negative. This is based off of the vertices. So negative 8, comma 2, minus 2 root 3 bracket union 2 plus 2 root 3 comma infinity. And the range is negative infinity to positive infinity. Okay, now let's move on to the last and final one, which is the hardest, because we had to turn this into standard form. So let's do this. So dividing both sides by 32, we'd get 8 y minus 3 squared minus 2x plus 2 squared over 32 equals 1, and then this translates to y minus 3 squared over x plus 2 squared over 16 equals 1. And now just by looking at this, we can see that the center... Oh wait, first we need to determine if this is a horizontal hyperbola or a vertical hyperbola. So looking at the first term in standard form, it starts with y, meaning this is, in fact, a vertical hyperbola. Okay, so our center is at -2, 3. So let's draw that in. And a... hang on. And a, so the square root of 4 is 2, and the square root of 16 is 4. So, and 16 plus 4 is 20, so the root of 20 is 2 root 5, and 2 root 5 to decimal form is 4.47. Okay, and now we have to plot the vertices, so it's one's there, another one's here, one's here, sorry, this is -2, 3, so move everything. Okay, now let's draw in our box. Doesn't want to move a rectangle. Yeah, I'm just gonna erase this. Okay, now since this is asymptote, this is dotted. Now let's work on the lines. Okay, and now for the drawing, since this is vertical hyperbola. Oh, this is horrible. And that is our vertical hyperbola in time for the foci. So this is just based off of the point. So -2, comma 3 plus or minus 2 root 5. So where would those foci be? Hang on. So it's 4.47. So right around here. And right around here. And these are just the points doubled respectively. So this is just 4 and 8. And since this is a vertical hyperbola, the domain is -infinity to positive infinity. And the range is -infinity to 1 bracket union 5 to infinity. And that is our last question. Thank you for watching, and